Now in the session, let's see the range of probability. We need to understand the range of probability in understanding the values through their general understanding of probability. So let's recap with the definition of probability. To start with, we have for any event E, we have probability of E is NE by NS, and NE is number of outcomes favorable to the event E, and N of S is total number of possible outcomes. Therefore, we see that in this case, at the most, N of E is always less than, at the most being equal to NS. We see that this is less than or equal to this clearly. That implies N of E by N of S is always less than or equal to 1. That implies N of E by N of S, which I brought to the left, is nothing but P, which I'm going to substitute in terms of this. So this being P of E is always less than or equal to 1. Also, I identify that probability cannot be negative. So at the most, P of E is greater than or equal to 0, since chance cannot be negative. The chance of tossing of a coin cannot be negative, because we can understand that through the general understanding of the probability or the chance of happening and not happening. Therefore, P of E is always greater than or equal to 0, and this is less than or equal to 0. Therefore, connecting both of them, I have 0 less than or equal to PE less than or equal to 1 is what I get as the range of the probability always lies between 0 and 1. It does not cross 1 on the right or does not cross 0 on the left. Therefore, if I take it on the number line, I have the probability which lies between this, including 0 and 1. So probability of E always lies between 0 and 1, inclusive between. It doesn't lie outside of 0 and 1. Less than 0 or greater than 1 is how we understand the range of probability. At the most, here I get impossible event, because P of E is 0 at this point, and at the most it is 1 if it is a certain or a sure event, is how we understand the range of probability. Impossible event and certain event and the range of P is how we understand through the basic definition of probability as NE by NS. So now that we have discussed about the probability and few of the example problems connecting the definition of probability, let's see the learning outcome of what we have learnt about. Now we have seen different probabilities. The different situations or the different events gave us the different values of probability. Now let's come back to the question on why the international cricket matches use tossing of a coin for deciding on the batting or the fielding, the bowling decision, which is taken generally by tossing a coin. Why is it that tossing of a coin is taken as the chance of deciding which team wins and which team loses? To identify this, let's come with tossing of a coin and see why it is used through a more mathematical, valid understanding and justification. When I toss a coin, I have seen clearly in my previous activity of tossing a coin, initially I got the head, and in the second chances I got the tail. So my probability when the event is tossing of a coin, then probability of getting a head was 1 chance out of 2, and my probability of getting a tail is 1 chance out of 2 equally. That is, in this case, the percentage of chances is half times 100, which is 50%, and in this case also I get percentage of chances is half times 100, which I get to be 50%. So the winning and losing, or getting ahead and not getting ahead, has equal chances in case of tossing of a coin. And because of the equal chances of either teams winning on getting ahead or a tail, or winning on deciding on the batting or the fielding session, is decided on equal chances, and hence the international cricket matches decide on tossing a coin for deciding on whether the team wins or loses through equal chances. So this has come because of the equal chances is the answer. So this is one of the learning outcome, or there are many learning outcomes through which we can estimate things through the probability connected with mathematics or daily life.